Okay, perfect. All right, so thanks everyone so much for joining the second of our 3 SQL workshops hosted by the Data and Analytics Club and the Marketing Club at Foster. So we will be posting the links after all of this for the recording and for the slides in the Data and Analytics Slack channel. So please join that if you haven't already. And if you're an evening student, just let us know if you don't have Slack access yet, and we'll be collecting all of those names and sending them to our technology rep to get those added. So without further ado, I will pass it to Sarodik, who's going to lead us through the second workshop on joins.
Right. Thank you so much, Alicia, for that wonderful introduction. Very good morning to everybody who's joining in today. Just give me 1 second. I got like Right. So thanks so much. Brief glitch there. So let's get started right now. So as Alicia mentioned, today we're going to be focusing and we're going to be advancing on some of the topics that Kevin covered last time around, starting from the very basics. And today we're going to be doing something a little bit more advanced, but something that's fundamentally quintessential to SQL itself. This is what I would sometimes call the heart of SQL, and it's joins. So without further ado, let's get started. We all covered this, so I'm going to be doing just a very, very basic recap of what Kevin did last time, and I can take it from there. So we all know, for people who were in the last session, you got a brief overview of what actually SQL is. It's a query language. The acronym actually stands for Structured Query Language. And we also went a little bit into what the scope of this workshop is and what lies outside of the scope. Feel free to just peruse through those. A recap of what we mean. So SQL by itself is a relational database. Nowadays, you're going to be hearing a lot of things about non-relational or NoSQL databases as well, but that's not what SQL is. At its heart, SQL is a relational database system. It's called relational because there are clear relations between the different entities that are available within your databases. And we'll actually start to delve deeper into what these relations are when we talk in depth about joins. Here's just a brief recap for people who may not have been able to attend the first session. So these are, in my opinion, the only basic syntactical elements that you will need to know to be a part of this session, today's session. So here you can just see that when you want to view multiple columns from a SQL table. Alicia, do feel free to let me know when there are any questions in the chat, because I can't really see the chat. Yeah, but thanks. Yeah. So when you want to view multiple columns in a SQL table, this is the syntax. So you select and then put the column names, and then there's a from, and then you specify the table from which you actually get these values. When you want to view all columns, this is like the most common SQL query that you'll see floating around. It's select star, which stands for select all of the columns from a SQL table. When you want to filter down the values, you use a select star. So here you can just as well use the specific columns that you want to view, but it's select star from the table, and then you have a where condition where you specify the value. So let's say you only want to see values for a particular column. So there you specify the value that you want to see. It can be numerical, it can be a string, doesn't really matter. The next function we looked at was sorting. So how do you actually sort values when you do a select statement? And you do that by using the order by function. And you can sort both on an ascending basis or a descending basis for a particular column. And then finally, we had a look at aggregate functions. For the purpose of this session, we don't really need aggregate functions at all. Vivin will actually be covering that in much more detail in the final session in this series. So that's just a brief recap. Now let's talk about joins. So as you can see here, joins are essentially a way by which you can extract information from multiple tables in your database. And here, if you just glance at this, you'll realize that why essentially do you need joins? It's that well, your relational database will have huge amounts of data, right? And you can't really compile all of that data into a single table because that just wouldn't be space optimized. That just wouldn't make sense from a maintenance perspective. So you split that data across multiple tables, and you have what are called relational identifiers between these tables itself. Now, that's well and good. You've put the data in multiple tables. What do you do when you actually want to extract the data from these tables? That's when you use joins. So this is just the foundational usage of joins as they are. And you don't need to look at the images that I have here, but I just want to get you acquainted with what essentially happens in a join. So let's say there are two tables. So as you can see here, there's a customer table that we have, and there's an orders table. And there exists a relational arrangement. So here we have the names of customers along with customer IDs. And here in the orders table, we have which customer has placed which order and on which date. So as you can see, there's a relational arrangement or relational just basis between these two tables based on the customer ID field. And this sort of relational arrangement is what's referred to as a foreign key in a SQL. Don't worry about knowing the in-depth of what a foreign key actually means. Just know that it's called a foreign key, and for the purpose of joins, you don't need to know too much about foreign keys at all. I'll guide you through that when we do the hands-on session. Now, essentially what happens is we use these sorts of relational arrangements to connect the data across multiple tables and then view data from multiple tables itself. So that's just what the base is, the very foundation of a join looks like. I'll stop right now and ask if you guys have any questions at this point. Anything goes, guys. Cool. I assume you guys will have more questions as we get into the hands-on itself. So let's trudge forward. So now I want to talk about the types of joins. So joins come in different flavors, and for the purpose of this session, I'll be focusing on the most common joins. Truth be told, there are other joins apart from this, as you will see in this brief note that I have at the bottom. There are other joins, but they are rarely used in a practical context, if ever. But the most important joins that are the most frequently used is the one that you see here, what's called an inner join. Other joins that are used less frequently are what are called left outer joins, right outer joins, and full outer joins. I won't be discussing the full outer joins today because, truth be told, working in SQL for almost 5 to 6 years, I never really used full outer joins at all. But the inner joins and these two other joins, the left and the right, are something that we will be discussing today and will actually be fundamental to your understanding of how joins work in the SQL context. Next, right. Feel free to just glance over this slide. I mean, I don't expect you to understand anything about this at all, but this is actually the very basic syntax of a join. So down the line, if you forget what the syntax, and when I say any join, I mean any one of these joins. All of these will fall into this syntax itself. You don't have to understand what it means absolutely. That's fine, but keep this for ready reference down the line. If you do forget the syntax, you can leverage this to quickly transfer this over to whatever it is that you're working on. Okay, yep. So now we actually, I'm going to try to get over to the practical applications. And let's just see what this actually looks like. So like I said, we have a customers table, which has a customer ID field in it. We have an orders table, which again has a customer ID field in it. And this customer ID is actually linked to this customer ID that you see in the customers table. But how then exactly do we extract information from both of these tables? Well, we use something that you see at the bottom left over here. We use this sort of a query. Now, I'll actually transfer over to using the W3 School SQL interface to take you guys through what this actually looks like. And feel free to follow along with me. If you have any questions, do feel free to ask. If you're facing any technical difficulties, also feel free to ask as well. I'll be happy to chip in as much as I can. But let's look at what an inner join actually looks like. So I'll write everything from scratch so that you guys can follow along. I'll remove all of this and I'll write everything from scratch. First, let's have a look at what these tables actually look like. So we'll do a select star from orders. So here you see we have a customer ID, and I'll just order by the order ID, let's say. So you guys may remember from the first session that case is not an issue in SQL at all. So it can be uppercase, lowercase, doesn't really matter. So here I've sorted by the order ID. We have the order ID, the customer ID, employee ID, order date, and shipper ID. Let's have a look at what the customers table looks like. These are the two tables that we will be working with. On the customer side, we again have the customer ID and a whole bunch of information over here. Now, let me ask you guys a question, and anybody feel free to chip in here. What's the common field between these two tables that we have that we're going to use in our joins? Anybody? Do you want me to run the orders table? Yep, I see something in the chat. That's great. Thank you, Erica. It is actually the customer ID, right? So we're going to be using the customer ID to join these two tables together. Let's have a look at what that actually looks like. And so I'll go really slow here so that you guys can follow along. So let's start. Select. Let's first start with a very basic select star from. Let's stop there. The next component, let's switch over here. We're going to put the name of the customers table. So we're going to put customers, select star from customers. And I'm going to put something that's called an alias. So this alias is, it can be any value at all. It can be C, D, A, B, C, D, doesn't really matter. But this is just a way of referencing this table itself, the customers table. And you'll see where this is actually going to get used. So yeah, up until now, we just did select star from the customers table and put an alias on it. Now actually comes the join turn. We write this. So these are reserved SQL keywords. We call it an inner join. And after so this is the first table, the customers table. After this, we put in the second table that we want to join on, which is the orders table. Just like as we did with the customers table, we will put an alias for this as well. Yeah, order so. Now, if you guys remember from the orders table, we had an order ID, we had an employee ID, customer ID, and from this customer table, we have a customer name, address, city, and so forth. Now, let's say that I want the customer name from the customer table. So I'll just put C, which is the alias for the customers table, dot customer name. This is just the syntax that we use. Again, let's say I want the city from the customer table. I'll put C dot city. Now, let's say I want the employee ID from the orders table. In that case, I'll put O dot employee ID. And the reason I put O was that O is the alias for the orders table. Now, this is where the utility of a join is. We're essentially getting fields from multiple tables in a single query. You're getting it from the customers table. You're getting it from the orders table as well. This is essentially what a join does. We're still not done. There's one other thing. So I asked you guys, which is the field on which we actually want to do that? Or because SQL won't know which field is common between the two tables, right? We have to put that in. What we do there is right after we put orders O, we're going to do on. This is again a reserved SQL keyword. On. Now we use these aliases again. C dot customer ID equal to O dot customer ID. Sorry, I messed up the case. This is essentially telling SQL that, hey, the customer ID column in the customer's table is to be joined with the customer ID column on the orders table itself. So this is that relational identifier that I was talking about. Does this make sense? Any questions here? This is how we explicitly specify what the relational identifier between the two tables are. Yeah, Aaron?
Just quick clarification on the aliases. So
Yeah.
whatever you put down, it can be anything you put down afterwards, and that becomes the alias for that.
Exactly.
Okay, got it.
Exactly. It can be anything. But just remember, if you change the alias, you have to change the alias reference in every part of the query, or else it'll crash.
Gotcha. Understood.
Right?
Thank you.
So yeah, I'll just keep it at C for now. So now let's run the query and see what happens. Now you can see that I am now getting information from two tables, the customer name and the city from the customers table, and the employee ID from the orders table. Let me ask you guys a quick question. Now, what if I need the order ID from the orders table? What do I need to do? What do I need to add here? Anybody?
O dot order ID.
That's correct. Absolutely right. O dot order ID. Run it again, you get the new column. Right? So it's as easy as that. Anything that you want to add or remove now, let's say I want everything. Plain old select star. Now I get everything from these two tables. Everything that was there. Right? Hope that makes sense. Now, this is just an inner join. And what an inner join does is, so let me quickly show you guys why there's a difference between an inner join and the other types of joins. So, and let's quickly look at all of the customer IDs that we have in the, just bear with me a second, in the customers table, right? Keep a track of this. We have 1, 2, 3, 4, 5, 6, 7, and it goes on and on, right? Now let's look at the customer IDs we have from the orders table. Okay, let's do an order by so that it's ordered. Here, you're going to see that we don't have the, so for some reason, the orders table does not have the customer ID 1 in it. Now that's where an inner join comes in. Now let's transfer over back to where we had the join itself. And I'll show you guys what the results of the inner join actually are when we look at what customer IDs are being fetched. So I'll do C dot customer ID. Okay, this is something that you can disregard for now, this as. I just have to put this in because it's one of these syntactical issues. But what I'm basically trying to get at is I'm trying to look at what customer IDs are actually fetched by this query. Okay, I'm going to do an order by as well. Now you see that we've lost the customer ID 1 in the customers table. Can you guys see that? Right, I hope that makes sense, right? It means that when you do an inner join, only the values of this identifier that are present in both of the tables will be considered. Anything that is not present in one table but is present in the other, or vice versa, will not be considered. It will be removed from the resulting data set. Does that make sense? Because we checked, right, that the customers table did have a one customer ID, But now when we run this query, we see that that 1 has been omitted. And only the ones that match up are in this table, are in this, this resulting data set. Does that make sense?
So we do have a question in the chat of if we can repeat this concept one more time. I think one other thing that I actually would like to add is if you scroll all the way up to the query itself, I don't know if we've talked about this syntax yet, but where you see the word as C1 and then as C2, where that's coming through is actually in the labels for the columns themselves. So exactly. If you don't want like a really gross like table column name in your results, you can actually relabel it so it makes a little bit more sense in the actual output.
Exactly. And so I think it was Shannon. Yep, sure. I'll be happy to repeat that. So I guess you saw that the customers table had the record for customer ID equal to 1, right? We saw that it was there, right? I can run it again to show you guys. See, the customers table had a customer ID of 1. But when we run this, the join query with an inner join, the 1 is lost because there was not a 1 on the orders table. I'll again show you guys. So here you saw that, oh shit, sorry. Here you saw that there was no customer ID of 1 in the customer table, right? And so essentially when we did an inner join, anything that was not present in either of the tables was disregarded, and only the values that were common were fetched by the query. Does that make sense? Any questions here, guys? I hope that makes sense. Cool, cool. So this is what an inner join essentially does. I'll take you over to the table. So if you look at this Venn diagram, an inner join only gives the results of what's common between the two tables in terms of the relational identifier. Only values of the relational identifier that are present in both tables will be returned by an inner join query, right? I hope that makes sense. Feel free to, but that's essentially what you need to know about inner joins. Now let's have a look at what an outer join looks like. I'll again start, sorry, a left join looks like. I'll again start from scratch here. Now, let's have a quick look again at what, so disregard the case, guys. I'm just typing all over the place. So here we know that our customer ID goes from 1 through blah, blah, blah. And I'm going to do orders and order by 2. Don't get bogged down by what this actually means. It's just a short way for me to do the ordering, but you guys don't need to know that. So in the orders table, we don't have a customer ID of 1, right? Now let's rewrite our entire query. I'll quickly do the entire query all over again. And I'll do c dot customer ID as C1, CO dot customer ID as C2. This is exactly the same query as we had last time. The only difference here is that we now have a left outer join instead of an inner join. Let's see what we get here. Now, it's very crucial to know. So if you guys remember last time, we did not have the 1 at all. Now we're getting the 1 from the customers table, and any value in the order table is being displayed as a null. And this is essentially what a left outer join does, is that any table that's to the left. So remember this, this is just an easy way to remember it. when you use a left outer join, any table that's to the left of that syntax of this line, so before that line, all results from that table will be fetched when you're doing a left outer join. So I repeat, any table that's to the left or before. So if I write it like this, it's to the left, right? The customer's table is to the left of this left outer join syntax, right? Any table that's to the left, all records from that table will be fetched when you do a left outer join. Does that make sense? And any value that's not there in the right table will be returned a null. So we saw, right, that the orders table did not have a customer ID of equal to 1. But since we're creating a 2D table over here, there has to be some value corresponding to this, right? But there was no value in the orders table itself. So what SQL does, it intelligently replaces that with a null value. This was maybe a lot more information. I'll stop a little bit to ask you guys if you have any questions, and I'd be happy to go over the entire thing again. Any questions, guys? No bad questions. Nothing is off the charts here. Feel free. I'd be happy to help as much as I can here. This is your time. Use it as much as you want. Okay, so that's essentially, I'm assuming there aren't any questions anymore, but if there are, please feel free to raise your hands or put it in the chat. Okay, I see something in the chat. Okay, that's a good question. So yes, so in R, what we do is so here's a little bit of a difference between the two. I'll be talking in technical terms. So R is at its core a programming language. SQL is, however you might want to phrase it, SQL is not an object-oriented programming language. SQL is a querying language. So there's not really the kind of assignment that you can see in R, but there are something called, I'll write it down here, temp tables that you can create to temporarily store the results of a join query in. So you can create something that are called temporary tables, or you can create something that are called table variables. But these again are beyond the scope of this course. So feel free to look these up if you want to. But yeah, essentially the assignment kind of thing that you see in R doesn't really hold in case of SQL, because SQL is not an object oriented programming language, which R is. And you may have other, so you may have heard of other object oriented programming languages such as Java, Python, blah, blah, blah. Yeah. So not to dive too deep in the weeds there. So essentially, coming back to point, I'll just move this to the next line. This is what a left outer join does. It takes all of the records from the left table itself, from the left position table, whereas an inner join only takes the records that are common between the two tables. So let me just quickly hop on over to here. So here you'll see that the Venn diagram has changed a little bit. The Venn diagram essentially says, now I'll take all of the records that are available in table 1. I'll take the ones that are common between table 1 and 2, and anything that's only in table 2 will not come into the picture at all. And this was the part that I was talking about. If a value of the identifier is not found on this right table, so if such a column is in the select statement, the right table value will be null, as we essentially saw here. So we did not have a 1 in the one customer ID in the orders table, right? So SQL replaced that value with a null when it was displaying the results. Any questions, guys? Because if you've got this in place, right outer join will take you like 5 minutes tops. It's the exact same, but with the orders flipped. Any questions, guys? And we'll also deal with when we actually use these joins as well. What are the specific use cases? But right now I want to focus on the syntax itself. Any other questions? Okay, so in the interest of, yep, we do have a chat. So like I said Michael, it's whichever table is to the left of this left outer join syntax. Whichever table is to the left of this left outer join syntax will be the left table over here. That's how it's determined. So you're actually essentially right. You put the table, you put the alias, then you put the left outer join syntax, and then you put the second one in. And that's the positional placement of what's constituted as left in the left outer join. Right, guys, I'll quickly hop on because 11:05, yeah. Let's now do right outer join. And for right outer join, I may have to change the table order here. So we will no longer be working with, now we'll be working with the orders and employee tables. So let me show you guys. Let me show you guys what we're dealing with here. So essentially here we have, something which is called the employee ID in the orders table. And this will now be our relational identifier. And let's check out the employees table as well. In the employees table, we also have the employee ID, right? So now this will be our unique identifier. Let me check if this was indeed the case. Yeah, it was the employee ID. So now let's do a right outer join. And for the right outer join, we want everything in the employees table. Does that make sense, guys? We want everything in the employees table, right? So remember, it's the same as what we did in the left outer join. Now, when we're using a right, from whichever table we want everything, that needs to be to the right of the right outer join syntax. So let me ask you guys, if employees needs to be to the right of the right outer join syntax, what do we place here? Which table do we place here? Which will be, so I'll make this easy as well. What do we place here where I've written 1? And what do we place here where I've written 2? Remember, we need every piece of information from the employees table, and we have a right outer join. So what do I place in 1? What do I place in 2? Any thoughts?
I will place the orders as the first table, and the employee table as the second one.
Absolutely, Joey. That's absolutely right. Oh, sorry. And we have the familiar syntax, O dot. Now, let's see what we get here. Let's just see. Okay. Let's just see what we get, and then I'll dive into. So remember, the first column is from the employee table. The second column is from the orders table, and we wanted everything that was in the employee table. That's exactly how we wrote our right join statement, right? Okay, I see there's a fault here. It's outer join. Oh, okay, maybe. Okay, I see. Damn W3. Okay, this is something that I didn't anticipate. It's not running. I mean, apparently it's not supported unless I messed up the syntax. Are they?
Oh, is it that extra space in your E2 and from?
Actually doesn't matter. I don't think it matters.
I have it working on mine.
Oh, really?
Yeah.
Oh, okay. I think from. That's strange. Right.
We have a comment in the chat that the table name might be wrong.
Table name, it seems employees, right?
I think My question is just about the fact that you're pulling the employee in the order, right? So you've got employee up on the top, and you've got employee. So
Which
don't you
one?
need some up
Okay.
there?
Yeah.
So I just had no spacing in the name, and it worked for me.
No spacing in which name?
So up in the first line.
Yeah.
Out there.
Yeah.
Use the smaller. Yeah, exactly. So that had no spacing, and I used lowercase, but I don't know. It seems to work for me.
That's strange. Can somebody pay? Yeah.
Yep, I
Thanks,
just put it in the chat. So this is actually the direct one from if you navigate to like the specific right join section in this page, this is the what it uses.
It still says, am I missing something over here? It still says that.
It
but not
seems missing the semicolon.
I don't think
Does
that
it
should.
matter?
Not really. It shouldn't.
Let me try to repeat what you wrote.
Yeah, but yeah, let me quickly refresh the page. So here we have blah blah blah. Let me quickly do something from orders. Right. Join employees on orders.employee employees. Is there any way this is messing it up? No such call. Okay, shit. Sorry. I actually tested this. See, the left join is working. Damn it. Okay. So guys, a little bit of a snafu over here, but the good part is it's so in the truest sense of the term, you never need to use a right join at all. You can get by doing everything that you can do with a right join just using the left join. What's the trick here, guys? So I want to see how can you avoid using a right join at all? Always use a left join. What's the trick here? What trick do you think I can use? To always use a left join, and yeah, let's see the chat. Exactly. So we just swap the orders of the tables over here. Given that you can do that, you never ever even need to use a right join at all. You can get by with doing anything using just a left join. And we already saw what the left join functionality looked like. So it'll work in the same exact way, and you can get by with knowing just one of them. But yeah, again, I do want to stress on the fact that in a career in SQL, I've only used like left or right joins only about 10% of the time. Most of them are almost always inner joins, almost like 90% of the time. So if you have the inner join in place, I don't think, yeah, at least for an MBA, if you were doing like a job that was mired in SQL, that's a completely different question. But for an MBA, the inner join does most of what you would require from a database functioning perspective. I said we would talk about the use cases. So this is not something that's earth-shattering. It's just when you need records from both of the tables, you use the inner joins. When you need records that when you need all of the records from one particular table, and you're okay with if those records are not present in the other table or not, you use either a left or a right outer join. Does that make sense, guys? And I would advise you to always, so Vivian's going to be touching upon something called nested subquery in the next section. They're really useful as well. But given for simple use cases, when you need data from multiple tables, always use a join, because it's much more performance oriented. It's much better in terms of performance. It takes up lesser utilization and IO from the database itself. So whenever you can, always use a join. And the syntax that you will use is in this slide. This is the common syntax that you will always use. Just change it according to the join type. So we're at a place right now where I think we needed to be. There are a few things that I wanted to talk about, and those are table operations. But I want to stop and ask, are there any join specific questions, guys? Cool. Let's move forward. So here, we're going to do some table operations. And I remember that you guys asked, well, that's all well and good. I have multiple tables, but these tables, somebody has already made these tables for me, right? How do I start creating a table from scratch? How do I put data into it? How do I delete it? How do I update it? So here, I won't be referring to the slide. Please feel free to use this template in the slide. There's also a SQL file here. I'll be working on this. So I am now going to shift over to a SQL installation on my own system. Somebody I think mentioned that how do we connect to a database as well? I'm going to show you guys how to do that actually. So this is what's called a database instance. When you connect to a database instance, you're prompted for a password. And you're in. Okay, maybe not in right now. Okay, yeah, you're in. My bad. This is what actually a database looks like. So you have your, I'll try to be very brief about this, but when you're actually going to be querying, you're not going to be querying something like this on an online server or something like that. You're going to be querying an actual database. This is what an actual database looks like. You're going to have the databases on your side. Each database is going to have tables in itself. And there are going to be other things that we're not going to go into. These are really advanced SQL topics like views, stored procedures, and functions. But just know that within databases, you're going to have tables, and you can view these tables. And each of these tables will have specific properties such as columns and stuff like that. But now let's get back to what we were doing. I'm actually going to start doing this from scratch. So first of all, when you start an operation, you need to specify which database you're using, and you're going to use the word called use. So I'm going to be using this database called the test database. I hope you guys can see that. As you can see in the test database, I don't have any tables as of yet. The tables tab is empty. It does not have an arrow to the side. So what I'm going to be doing is first, I'm going to be creating a new table in this database. So I'm going to say use database. I'm sorry that you guys can't follow along with me on this, but please feel free to refer to this, the script, and feel free to write this down. I'll show you the commands as and when they happen. So I'm going to use test database, right? Yep. So this was run successfully. So now I'm in the test database itself. Now I want to create a table. The first thing I start with is I say create, then I say table. Somebody give me a name, anything goes. Looking for anything innovative, anything mundane, whichever goes. Bada Charles, go. So Charles table, right. And then now we have the name of the table in place. What's the next thing that a table has? So we have something along the horizontal axis, something along the vertical axis, right? We have, let's see in the chat. Size is a good thing actually, Mrinal, but let's talk about exactly, we have columns, right? So now I want to define the column names. The first thing I'm going to do is always best practice is to create an ID column. This will be your unique ID in the table. Next, I'm going to say what data type this field will be. It can be an integer, it can be a string, right? But it's always best practice to use an integer, and I'll say int. Next, I'm going to make this a primary key. Don't get bogged down by what this means right now. Just feel free to follow these for the ID field when you're creating a new table. Let's say I want a new column called first name. This first name can't be a string, right? Or sorry, can't be a number, right? We can have strings in it. So there, I'm going to say something that's called, you may have to remember this, and it's in the script as well. It's called varchar. which means variable characters. It means variable characters. So now I have the first name, which is going to be of type varchar. If I have a first name, I'm probably going to need a last name. Varchar. Don't get bogged down by what the 255 means. And so let's just stick with this, plain and simple. I now want a table that's going to have 3 columns, the ID field, the first name, and the last name. And I've wrapped this in a create table statement. Let me run this. Okay. Something error syntax. What's wrong with this? Okay, sorry. So now, if I refresh this, have a look at what's going to happen. Now we have an arrow on the side, and this says Charles table. So this is the one that I just created over here. Now, let me do a select star from this Charles table. What do you think I'm going to see? Any thoughts? What do you think I'm going to see here? Do you think I'll see any actual data? Yes, no, not entirely sure, don't really care. Which do you think is going to happen? Do you think we're going to see any data here? Not yet. That's correct, Ben. We don't have any data. We just have the table definition. So see, here we have an ID, a first name, and a last name, but we don't have any values yet. Now what I'm going to do, I'm going to put in some values. And yeah, again, refer to the embedded script, but please feel free to follow along as well. What I'm going to do is now I'm going to insert a row. So I'm going to say insert into the name of the table. Okay, what the hell? Okay, Charles table. I'm going to say the name of the columns. This is just the way we write this syntax, guys. The names of the respective columns. And then I'm going to give, in the same order in which the columns are there, I'm going to give the values, which is going to be 1 for the ID, Charles for the first name, okay, and I don't know, Joe for the last name. When I run this, so I hope you guys can all see this. I'm going to quickly run this. Now let me do a select star. Now do you think I'll see data in the table? If you've been following along, you should be saying yes. See, now I have 1, Charles, and Doe. So that's how you actually insert data into a table. Now, what are some other operations that you might be doing? You want to update the data, right? You want to really, so let's say you want to change the Doe to, I don't know, Mo, right? In that case, what you do is you write an update statement with the table name. Then you use something called a set, and you mention last name. You set the last name equal to Mo. Now, this last part is really, really important. You have to put a where clause here. You have to put a where clause for which row you actually want to update. And which is the row I want to update? I want to update where the ID is equal to 1. So I'm going to say ID equal to 1. Right? I hope this makes sense. So update, and this is really intuitive when you actually think about it. I want to update Charles table. I want to set the last name equal to Mo, where the ID is equal to 1. Let me quickly run this. Now, if I do a select star, I don't know why my IntelliSense is not working. Okay. You'll see it's gotten updated to Mo. So this is how you update records within your table. Finally, let's say I'm done with this. I don't need this table anymore. Oh, yeah, although in real world scenarios, you probably never would delete an actual table. But let's say you, right, okay, let's do this. I want to delete this row now. I want to delete this row, in which case I'll write delete from Charles table. Again, it's absolutely important you use the where here. If you don't use the where, it's going to wipe out everything in your table. absolutely important that you use the where ID equal to 1. If I run this now, so delete successful. Now if I do a select star, okay, in hindsight, I probably should have named this something else. Charles table. Now you see we don't have any data at all. It's been deleted. And now finally, let's say I want to delete the table altogether, not just the data in it. Very plain and simple. Use drop table, Charles table. If I run this, see now the tab on the left went away. Now the table has been dropped. There's no existence of the table left at all. No shred of existence left at all. And that, ladies and gentlemen, is essentially a few of the very basic table operations that you'll be doing in SQL. I know this was a lot to take in just 15 minutes of time, but feel free to refer to that SQL slide, and Alicia will be sharing the PowerPoint as well. The SQL file is going to be embedded in that PowerPoint. So how to create tables, how to insert data, update data, delete data, and then delete the table itself. Everything is in that slide, will be in that file. So yeah, that's it, my little pitch, and I'll open it up to any and all questions right now.
I am going to put the feedback survey in the chat. We would love your feedback just for this session, for moving forward with our last advanced SQL session, and then for if we decide to do these again in the future.
Thank you.
Absolutely, guys. Have a great rest of your day. Bye.
All right. I'll stop recording.